Good day, everybody. How are you all? Hope you're doing great today. Today, we are going to talk about how to find variance of a binomial distribution. So, here I go. So, after a coin is, no, a fair coin is tossed 4 times. Assume success is for the coin to land head face up. Assume that the probability of obtaining head is 0.5. What will be the variance in the number of heads? So let's get into solution. So this is a binomial distribution because there are only two outcomes. There are only two outcomes possible. One is success, which is heads, that is heads. The other is failure, which is tail. Failure, it is tails. So either you have a success or you have fourth. So your N is number of trials is equal to 4. Your P, small p, is probability of success. In each trial, which remains constant, is 0.5. Okay. And X is equal to number of successes in 4 trials. So, move this a little bit. So X can have value of 0, 1, 2, 3, and 4. A value of 0 means out of 4 tosses, we do not get a single head. We do not get any head. A value of X equal to 4 means out of 4 tosses, all the 4 tosses will be heads. So, um, so let's try to find out what is the probability of X equal to 1. And that is equal to, by binomial formula, it's n c x small p raised to the power of x and multiplied by 1 minus p raised to the power of x. So what is ncx? This is number of ways in which we can select x items out of n items. Without regard to order. And without regards to order, that is called combination or combination of x items out of, oops, sorry, what's happening? So let's take care of this. Let's write this again. So number of ways, WAYS, in which we can select X items out of N items without regard to order. Without regard to order. Regard to order. This is also called OR. That was what I was going to write. Combination of X items out of N items. N items. So if we plug in the formula for P, let's do the calculation of, let me correct this, and let's do the calculation for Px equal to 0. Okay. Let me do one thing. Let me just write this as P of X. This is P of X. So this is the probability of X successes out of N trials. Okay. Do not quit right away. I'll give you some important hint at the end of this program. Important tip at the end of this program. So as I said, the lowest value of X is 0. So let's do the calculation for X equal to 0. Okay, so let's move this up a little bit. So for X equal to 0, P of 0 is N is 4, combination 0 multiplied by probability of success is 0.5 raised to the power of X is 0, that is I'm not getting any head at all, multiplied by 1 minus 0.5 raised to the power of N minus X, which is 4 minus 0. Or in other words, 4C0, which we will find using the calculator. 4, then I'll press the math button, then highlight PROB on the top row, then number 3, and I'm taking 0 items out of 4 without any regards to order, and that is 1. So that is 1 times anything raised to the power of 0 is 1, and multiplied by 0.5 exponent 4. And that is equal to, so I type 0.5, then press the exponent sign, and then 4. And that is equal to 0.0625. And we can repeat the calculations for X equal to 1, X equal to 2. I will show you another one, which is for X equal to 4, it will be P of 4 will be 4C4, 0.5 raised to the power of 4 multiplied by 1 minus 0.5 raised to the power of 4 minus 4. Or 4C4, if you do it in the calculator, 4 math, highlight PROB on the top row, the number 3, 4 combination 4, that is 4 items taken out of 4 items without regards to order, is 1 times 0.5 raised to the power of 4, we already know is 0.0625, and then it is multiplied by 0.5 raised to the power of 0, which is 1. So the final answer is 0.0625. So basically we can make a table of discrete binomial probability distribution in this case. binomial probability distribution. Probability distribution. So I will have all the values of x listed and the corresponding probabilities, x and p of x. So as I said, x is 0, it is 0.0625. Now we can repeat this calculation for x is 1 and it becomes 0.25. Then x is 2, it is 0.375. And x is 3, it is 0.25. And x is 4, and it is, we have already shown it is 0.0625. So this is a listing of all the possible values of x and the corresponding probabilities. Now, please do not quit. I'm going to show some important tip at the end of this program. Okay, so we will use the formula for the variance, okay, of the discrete probability distribution. Okay, so in an earlier uh, presentation, I have shown you what is the mean of this binomial distribution. Actually, the mean, if you remember, mean, let's do it over here. Mean is equal to n times p. And I showed you how this formula is derived. In any event, the mu x, or let's write it as just mu. Mean mu is equal to n times p. N is 4 and my probability of success is 0.5. So it is mu is 2. This is to be this is important because the next calculation I will do is x minus mu, okay? And that will be, for the first one, it will be 0 minus 2 is equal to minus 2. Then it will be 0 minus 1 equal to minus 1. Next one will be 2 minus 2 equal to 0. Next one will be 3 minus 2 equal to 1. And the next one will be 4 minus 2 equal to 2. Then I will square this deviation from the mean. This x minus mu is the difference or deviation of each number in the distribution from the mean. So I'll square this deviation. So minus 2 times minus 2 is positive 4. Two minuses make it positive. Minus 1 times 1 is positive 1. This is 0, this is 1, and this is 4. Now I will multiply. So let me create some space. Now I will, okay. The next row of data will be x minus mu squared, which we already determined, multiplied by the corresponding p. So in this case, 4 times 0.0625. Okay. Next one will be 1 times 0.25. Next one will be 0 times 0.375. Next one will be 1 times 0.25. And the last one will be 4 times 0.0625. So basically, the square of the deviation of each number from the mean, which is x minus mu square, I multiply by its corresponding probabilities. Hence, x minus mu square times p. If I do the calculation, 4 times 0.0625 is 0.25. This is 0.25. This is 0. This is 0.25. And this is 0.25. Okay. Let me check. and make sure. Okay. So the definition of variance for a distribution, variance for a discrete distribution. Discrete distribution, which is binomial, is a discrete because we can have 0 heads, 1 head, 2 head, 3 head, and 4. These numbers are discrete numbers, discrete random variable, where variable is number of heads you are getting in 4 tosses, is given by sum of x minus mu square multiplied by the corresponding probability. Basically, it will be sum of the column that we get. So in our case, sigma square is equal to, we will sum sum of x minus mu square times p, which is equal to 0.25 plus 0.25 plus 0 plus 0.25 plus 0.25. Okay. Interestingly, all the quantities are 0.25 except one, which is 0. And now we will do some algebraic manipulation, as I will show you in a minute. So this can be written as sigma square is equal to, I'll take out the 0.25 outside, and this will be 1 plus 1 plus, forget the 0, next one will be 1, next one will be 1. Okay. So sigma square. Now 0.25 can be written as 0.5 multiplied by 0.5, and inside the parenthesis we have 4. Remember, our probability of success P is equal to 0.5, and our probability of failure 1 minus P is 1 minus 0.5 is also 0.5. Our N is 4. So sigma square. So sigma square is variance is nothing but first 0.5 is P, next 0.5 is 1 minus P, and what is the term 4 in the parenthesis? It is N. So variance of a binomial distribution is equal to N times P times 1 minus P. So our sigma square in this case is 0.5 times 0.5 times 4. Okay, times 4, which is 0.25 multiplied by 4, which is 1. So that's your answer. Variance. Initially I used the formula for the variance of a discrete probability distribution, and then for this particular case of binomial distribution, I showed you how it can be reduced to a simple term for the variance. Variance is equal to N times P times 1 minus P. In this particular case, when N is 4, P is 0.5, and 1 minus P is also 0.5, it reduces to 4 times 0.25, which is 1. So 1 is your variance in this particular case. So point to note, variance for binomial is N times P times 1 minus P. Why it is so? We proved it by using the formula for the variance of a discrete probability distribution, where we took each value of x, the discrete random variable, from that we subtracted the mean. This x minus mu is called deviation of each number from the mean. we squared that deviation and multiplied the square of the deviation with the probability, corresponding probability. Did it for all the values of x and added them together, got the variance as 1, same as using the formula for variance of a binomial distribution, which is sigma square is n times p times 1 minus p, which is also 1. Point to note, we can use the simple formula instead of using the discrete probability distribution variance formula, but either way, we come to the same answer for the variance. Now, there's a quiz question in the top, is what is the standard deviation of this binomial distribution? And that we will solve in the next video, okay? So if you like this video, please give me a thumbs up. I really appreciate that. That motivates me to produce more interesting videos just to help you. And if you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button and let YouTube know that you like to be notified when I upload a new video. And please do not forget to watch me tomorrow when I will try to solve the quiz problem. That is, what is the standard deviation of this particular distribution? Okay. Thanks for watching. Have a nice day. Take care and see you next time.